times 10 to the power 3 squared minus by our stress average, which is equal to, let me go to the next previous page, 16.977 minus by 16.977 times 10 to the power 3 squared, and then the whole thing divided by 3. Okay, square root the whole thing, so this will be equal to 42 power 3 squared minus 16.977 power 3 squared divided by 3, and then square root the whole thing is equal to 22.179. Okay, 22.179. Okay, times 10 to the power 3 psi, and this is our tau max. Okay, so now we have to relate. Okay, we have to relate tau max to shear xy to find our torque in the y direction. Okay, so I'm going to paste the mole circle again. Okay, to show you where we are. So we know that the distance or this height that I'm drawing now down here this is our tau max, right? So what we have to find, or what we know, is the distance from here to here. We know, right? The distance from here to here we found out, which is equal to 22.179 times 10 to the power 3, right? So now all we need to do is to find this height now. Right, we have to find our tau xy. Right, and then we also know this distance is 16.977 times 10 to the power 3. Right, so now by knowing that, right, you just need to say that shear xy is equal to square root of 22.179 times 10 to the power 3 squared, right, and then minus by 16.977 times 10 to the power 3 squared. Okay, so this will be equal to 22.179 power 3 squared minus 16.977 power 3 squared. Square root is equal to 14.272 times 10 to the power 3 psi. Right, so from here we know that the shear xy is equal to the torque in the along the y-axis, about the y-axis, multiplied by c divided by j. Okay, so this will be equal to 14.272 times 10 to the power 3, and then this will be equal, torque in the y we're going to find c divided by pi over 2c4. Cancel is become cube. So ty, or torque about the y-axis, is equal to 14.272 times by 10 to the power 3 multiplied by pi over 2 multiplied by 1.5 divided by 2 cube. Okay, so the torque is equal to 9.458. Okay, 9.458 times 10 about 3 pound inch. Okay, we know that. Okay, so next, the next one we can do it quite quickly. Okay, so next one, so we're going to compare with applying the same problem, but we're going to apply the maximum shearing stress criteria. Okay, anyone, any questions? Are you all okay so far? I know last lecture, while deriving it, wow, there's a lot to look at, right? But when you apply it, it's so straightforward. Okay, especially when you understand 3D Mohs circle, what is in plane, out of plane, why you have to construct 3D Mohs circle, okay, to identify stress A and stress B, your principal stresses. Any questions so far? Okay, I don't hear anything. So now I'm going to apply maximum shear stress criteria. Okay, so we're gonna apply. Okay, so find the torque using or from Tresca criteria. And Tresca, and based on Tresca criteria, we know that tau max is equal to stress U divided by 2. Right? So this is what we know. So this will be equal basically 42 times 10 to the power 3, right? Divided by 2. Right? And then this will be equal to 21 times 10 to the power 3 psi. Okay, and this is also equal to the radius of the largest Mohs circle. Okay, so regardless whether you use Tresca or von Mises, the Mohs circle will still be the same. Okay, so we're going to look at this Mohs circle. Okay, we're going to look at this Mohs circle. But something changed. Okay, and I'll tell you what changed. So when you apply to Tresca, this value over here, I'm going to swipe it out, okay? It's no more what? 22.1. It becomes 21 times 10 to the power 3. Okay? It becomes 21 times 10 to the power 3, right? The stress average are still the same, right? So I'll write down here, because we have done this already, I'll write down here, in future, you have to still construct right? Still construct 3D Mohs circle. Okay, you have to still construct 3D Mohs circle, right? So now again we want to find what? Stress xy. Okay, so stress shear xy, right? Now will become what? Now it will become 21 times 10 to the power 3 squared minus by what? 16.977. Hey, what am I doing? 16.977. Right. So this will become 21 power 3 squared minus what? 16.977 power 3 squared That's good. So it becomes 12.36. Okay, 12.36 times 10 to the power 3 psi, right? And then we're going to apply the same formula over here, right? Exactly the same formula over here, right? So I'm just going to bring this whole thing. Only one value change. Okay. So just bring over here. So that value change is this one. So now this becomes what? 12.36 times 10 to the power 3, right? So the torque is equal to 12.36 power 3 times by shift pi divided by 2 times by 0.75 power 3 is equal to 8.19 times 10 to the power 3 pound inch. Okay, so this one, the one before is also important. So you can see for yourself now. Okay, so the mole circuit is still the same. Okay, the only thing that changed is what? This radius over here. Okay, so but after you do that, you for using Tresca, you still have to check your stress A and stress B. Okay, so we are going to check. Okay, we're going to check stress A and stress B must be less than 21 or 42, right? Less than 42. Less than less than, is it 42? Because the yep, 42 plus minus 42 times 10 to the power 3 psi. Okay, we have to check. So for our case, our stress average is 16.977, right? So 16.9. So stress A and B is equal to 42 or 16.977. So minus 16.977 times 10 to the power 3, right? Plus or and minus by 8.19. No, radius of the circle, which is 21 times 10 to the power 3, right? So this will be equal to minus 16.977 plus by 21. So it's equal to 16.977 plus by 21 is equal to minus 37.977 times 10 to the power 3 psi. So these are the principal stress. Okay, so minus 16.977 plus by 21 is equal to 4.023 times 10 to the power 3 psi. Okay, so therefore stress A and stress B are less within plus or minus 42 times 10 to the power 3 psi. Okay, you have to check. Okay, right. So what we conclude from here, right? What we conclude from here is when we apply. So if you look at the torque, initially when we apply for Macy's, right? The torque we had was what? Was higher, right? Was 9.458. When we apply Tresca, right? When we apply Tresca, we get 8.19 pound inch. What am I doing? We got 8.19, right? Pound inch. Okay. So what you see is Tresca is more what? Conservative. And I did explain to you why. Okay. So if I'm if you I will not be too long. So if we look at our lecture, right? We draw this graph, right? Let me get back to there. We drew this graph. Hey, undo. Yeah, I'll try to. Yeah, me and my ambitious. Go on. Let me move things a bit. All right. So if you look at this circle over here, yeah. Sorry, I just have to move things around. So if we look at this circle or this diagram over here, don't worry, I'll change that, okay? Right? Don't worry. So XY. So this is your what X. I think I just drew that. Okay, let's not waste. So you can see that for the pink is von Mises, the maximum distortion energy. The area is bigger than what? Than the black lines, which belongs to Tresca. That's why the von Mises one, the value is bigger than Tresca. Okay, for this graph that we've constructed. Okay, so I'm going to end my tutorial now. Anyone, any other questions before I let you go? Anyone, please? Anyone? I don't hear anything. Okay, I'll let you go. Thank you for coming. Okay, the previous week I was talking to myself. Okay, thank you. Bye. Eugene. I'm going to leave it. Yeah, I'm just going to strike this off. Okay, thank you.